Okay guys, so now we have writing the inverse of a log function, and this is going to be multi-step examples. So we've covered this in the past video. Okay, we wrote the inverse of a log function. However, in that past video, it was only single step. So now we're dealing with multi-step. It can get a little bit more confusing, but it isn't too bad as long as you follow the rules. Okay, so we're going to go over the first problem here, and we're going to have y equals, so here we have y equals log base of 5, and then we'll do x plus 2. Okay, so recall in the previous video, right, that in order to take the inverse of a log function, we first must put it into its exponential form. Once we have it in its exponential form, we can then replace the y with x and the x with y. Right? Now, in the previous video, all of the examples I gave you, the log function was isolated. So what I mean by that, if we look over here, notice how our log function is isolated, log base of x. All right, that's what we're looking for here. Well, this is what we have here. We have log base of x. This 5 is my base, and this whole x plus 2 is my x. Okay, that is what we're looking for before we go ahead and put it into its exponential form. If it wasn't isolated like this, so for example, if I had plus 2 on the end here, I couldn't go ahead and put this into its exponential form. I would first have to subtract this 2, okay? And then I can put it in its exponential form because the log function is now isolated. All right, and we'll do an example like that after this one, but let's focus on this one right here. So again, this is isolated. So now we can go ahead and put it in its exponential form, which we're going to do here. So let's go ahead and write this as, so we'll have x, this whole thing is my x, right? So now it's being replaced, so it's coming over here. And we'll have 5 to the y power, okay? Now at this point, what we need to do, okay, it's in its exponential form. We now switch out the x with y and the y with x. So let's go ahead and do that. So I'm simply just going to replace this with y. And we'll replace this with x. Alright, we're almost done here. We just want this to say y equals now, so we subtract 2 on both sides. And that is done. That's all there is to it. Okay, so the inverse of log base of 5 of x plus 2 is y equals 5 to the x power minus 2. Alright, so this is your inverse. Okay, let's try another example here. So, getting a little more complicated, let's do the next one. So we'll do log base of 6. So we'll do y equals log base of 6, and we'll do x plus 2, and then minus 2. Okay, and this is a 6. Alright. So again, when we're taking the inverse of a log, first step is we need to put it into its exponential form. Before we do that though, we need to isolate the log function. Okay, so in other words, we need it in this form right here, log base of x. Well, here I have my base. Again, this whole part right here in parentheses is my x, but this minus 2 is getting in our way. So we need to add 2 on both sides so that we can isolate this right here. So let's go ahead and do that. So we're going to add 2. So we have y plus 2 now. Now we have log base 6 x plus 2. Okay? My log function is now isolated. At this point, I can now put it into its exponential form. Just be careful when you do this. This whole thing right here is acting as my y. This whole thing right here is acting as my x. Okay? And this 6 is my base. So we're going to go ahead now and rearrange this into its exponential form. So now we have x plus 2 equals 6. And we have y plus 2. Okay, good. Now it's in its exponential form. We simply just replace the x with y and the y with x. So let's go ahead and do that. So here comes the switch. So now we have y plus 2 equal to 6. Replace the y with x. Okay, last step, subtract 2, and we'll have y equals here. So when we do that, we get y equals 6x plus 2. And then again, we're going to subtract 2, so minus 2. Okay, and this is done. So this is the inverse. Okay, so we just took the inverse of this log function, and we found that it was this right here. Okay, let's try one more example here. So let's try erasing this. We'll have y equals log base of 3. And then let's do x minus 3. And then minus 2. Okay, again, they want us to take the inverse here. So following those same steps, we need to put it into its exponential form. But again, before we do that, we need to isolate the log function. Well, this negative 2 is getting in my way, because again, this is my b. This whole thing right here, this x minus 3 is my x. Okay, so this minus 2 needs to come over here. So we're going to add 2 on both sides. So let's do that. We get y plus 2 equals log base 3 x minus 3. Okay, well good. Now that my log function is isolated, okay, we're going to go ahead and put it into its exponential form. So again, just be careful here. This whole thing, I should put it in parentheses. Okay, this whole thing right here is acting as my y. This whole thing right here is acting as my x. Okay, so make sure you move all those terms together. Alright, so let's put it into its exponential form. So when we do that, we'll have x minus 3, okay, equal to 3 to that y plus 2. Alright. Good, now that it's in its exponential form, we simply just replace the x with y and the y with x. So let's go ahead and do that. And again, here comes the switch. So we're going to do y minus 3 equal to 3. Replace it, x plus 2. Okay. Last step, add 3 on both sides, so we have y equals 3 x plus 2, and then again we're adding 3, and that is it. So this is the inverse. So we just took the inverse of this log function and we determined this right here. Okay, so that is writing the inverse of log functions. Again, this is multi-step. So as long as you follow the rules, it's really not that bad. Just make sure you stick to those rules.